Okay, let us discuss few problem. This is related to the reactions of alkyne, and these are the easy problem. Basically, we will go slightly fast. So this says predict the product of reaction of one pentyne with the following reagent. So we have one pentyne. So let me write the structure of one pentyne. So 1, 2, 1, 2, 3, 4, and then you have 5 carbon. This is your one pentyne. So this first A part says if one pentyne react with one equivalent of HCl, what will the product? So this is reacting with one equivalent of HCl. So everybody knows this follow Markovnikov rule, hydrogen will go at the place where you have more hydrogen. You're getting? So hydrogen will go at this place and chlorine will go at this place. I think all of you are able to understand, and this is only one equivalent, so I will add only 1 mole of hydrogen and 1 mole of chlorine, 1 Cl and 1 hydrogen. So we will have Cl will be attached here and hydrogen is attached here. So there is no need to show the hydrogen, so Cl is attached at this position. I think all of you are able to understand this one. Let us discuss B part. So this says same molecule, if the same molecule is reacted with same molecule, I am not writing this, the same molecule reacts with 2 equivalent of HCl. So this time now I am changing, this is 2 equivalent of HCl. What will be the product? So you can write yourself, in this case what will be the product. Okay, everybody knows basically in case of alkyne, addition of both equivalent happens on the same. In the first case hydrogen is going at this place, another case hydrogen will go at the same place. You know, basically we have discussed this in the class. So here you will have 2 chlorine, 1 chlorine and another chlorine. Are you getting? So 2 chlorine gets attached on the same carbon, 2 hydrogen gets attached on this carbon. Now let us say C part. So C part says this time excess H2Ni. So the same compound I am taking, and this is reacted with H2Ni, but this is excess H2 in the presence of nickel, and this is used excess. And what will be the product in this case? Now this is a reduction. Now you are using in excess, so alkyne will be converted into alkane. So I will have simply this. Are you getting or not? So simply both double bond will get reduced. Now this C part, are you getting or not? So you initially see 1, 2, 3, 4, 5 carbon, 1, 2, 3, 4, 5. Here also you have 1, 2, 3, 4, 5 carbon. And the name of the compound is 1 pentyne. Now let us discuss C part. I think all of you have copied this one. So D part, the same molecule, if this reacts with, we are changing the reagent every time. This time reagent is H2PdBSO4, H2PD and BSO4. Now you know what is the product in this case. This is a Lindlar catalyst and it will do only one addition. 1 mole of hydrogen will get added and the product is cis addition. Are you getting or not? So both basically both hydrogen, so this will give you cis product, but in this case there is no meaning of cis product. So what is the product you will have? There is a double bond, and now this contains both hydrogen. So there is nothing like cis and trans for this case, because the same carbon contains 2 hydrogen. Cis and trans is only possible if this carbon contains 2 different groups, and this carbon is also containing 2 different groups. So if you have an alkene, cis trans is possible only if this contains 2 different groups and this also contains 2 different groups. It may be either A or B or maybe C or D different. So let us say A and B. So cis trans is possible only if this are not equal. So A is not equals to B, and then you will have only cis trans possible. Let us discuss E part. Same compound is treated with. Now if this is treated with 1 equivalent of bromine, so what will be the product? I think all of you can write 1 equivalent of bromine, Br2. Now this is the easy one. If you treat with 1 equivalent, now this is alkyne, only 1 mole of double bond gets added with bromine. So you will have this. and here we will have a double bond, and 2 bromine gets attached, 1 bromine attached here, and 1 bromine I can add here. I think all of you have copied this one. Now let us discuss next one. Same thing, F. What will be the product? The same reactant I am using, and the reagent this time is 2 equivalent of bromine. This time I am using 2 equivalent of Br2. What will be the product? Everybody knows the answer. There is a need to write or not? Okay, let me write. So I will have same compound, but now this time both this double bond also gets reduced. So you will have 2 bromine here. So 1 bromine is here. Another bromine you will have here. And here also you have 2 bromine. So 1 bromine, let me write this side. And 1 bromine I can write this side. So 2 bromine gets attached onto the same carbon. Because 2 equivalent is added, so both double bond gets reduced. Or you can say both double bond is added by Br. We'll discuss the next. So I'm removing this one. So let us say Z part. So G part says same compound if treated with, now this time this is treated with a cold dilute KMnO4. So this is cold dilute KMnO4. So if you treat this with cold dilute KMnO4, everybody knows only HOH will get added. No, OHOH gets added. In case of cold dilute KMnO4, if you remember, OHOH gets added. And now you can basically tautomerize OHOH. So let us do the product in this case. So you see in this case what will happen, you have to add 2 mole of OH. So I can write here because I need a space. So let me write. So this is here. Now if first mole of double bond if I remove and add OHOH. Now there is a cold dilute KMnO4 is in excess. So what I can do is I can remove this double bond also. So this is not the final product. So this is unstable. This is only an intermediate. And this, if I add finally 2 mole of OH, I will have 1 OH, another OH. On this carbon also 2 OH I have to add, 1 OH and 1 OH. And now this is also unstable. So this is unstable. So let me write this is unstable. So this is basically unstable. And this is also unstable. So what will happen in this case? It can lose 1 molecule of water. So if it loses 1 molecule of water from here, I will have a ketone. It also loses 1 molecule of water from here. So what you will have, if it loses 1 molecule of water from here and 1 molecule of water here. So you see, you will have a double bond O here at this carbon. And you will have a double bond O at this carbon. And there is a hydrogen. So basically this will give you a diketone. In this case 1 ketone and 1 aldehyde. So you will get 2 carbonyl compound. Are you getting or not? Even if you heat this one in the presence of conch, this double bond gets broken and you will have acid as the final product. Are you getting? If you take neutral dilute KMnO4 cold, in that case you will get diketone, and in this case 1 ketone plus 1 aldehyde, that is a special case. We'll discuss the next problem. So this is Z. Now let us discuss H. So this says if I treat with same compound, but this time this is a barm or a hot KMnO4. Barm KMnO4. You can treat this as a hot KMnO4. Medium is basic, OH minus also there. So what will the final product in this case? Now medium is not neutral. In this case medium is basic. We have already given you sufficient hint. Now you see, what we will have is, in this case you have to break this bond, because hot KMnO4 this will break this bond, and you will have COOH, and here also you have OH. So the product will be COOH plus, and here you will have H, C double bond O, OH, And now this is H2CO3. Let me see. This is a H2COH. So basically this finally it will give you HCOOH, and it further gets oxidized to CO2. So HCOOH gets oxidized to CO2. I am interested in this product, so this will give you acid. So if you treat with hot cheminophore, I have already said aldehyde gets oxidized to CO2. So this finally gets oxidized to CO2, HCOOH. That finally gets oxidized to CO2, and one part of the molecule you have this, and this will be COH. Of course, you have to acidify the solution also, otherwise you will get the salt of acid. So this is product after the acidification. So this is the acidified product. I think all of you are able to understand this one. Let us discuss next. I. So this part says, if I treat with sodium in liquid ammonia. Now this is sodium in liquid ammonia. What is this? So if I treat this compound, same reactant, if I treat with sodium in liquid ammonia, now you see this only reduces 1 mole of double bond, and this gives you trans, but in this case there is no point of cis or trans, so you will have final product is this. Are you getting? So in this case there is nothing like cis or trans, this will be the final product in this case. Now let us say J. So J part of the question says, if the same compound is treated with NNH2, so this is nothing but acid-base reaction. If you treat with NNH2, so you have a terminal alkyne. This alkyne has a H plus, so this will lose H plus. So you will have simply this minus Na plus. So this is a acid-base reaction. This is a simply acetylide formation. So this is a acid-base reaction. Nothing more important in this case. Now if I treat this compound, so the same K, if I treat the same compound with AgNH3 whole twice plus, you remember we have discussed this one in the class. So if I treat with AgNH3 whole twice plus, this will form metal acetylide. So I will have minus Ag plus. Did you remember? So I will have minus Ag plus. So this is a metal acetylide formation. I think all of you are able to remember this one. And now let us say L. And this is the last one. If I treat this compound with H2SO4 in the presence of catalyst HgSO4, you give me the product in this case. Now in this case what you will have, HOH will get added, H will add here, OH will add here, and now if you tautomerize, I am writing the final product. Here you will have double bond O, and here you will have so here you will have CH3. So HOH will add, so H will add here and OH will add here, and if you do tautomerization, this is the final product. So addition of H, OH, and then you have tautomerization. Are you getting? You will get, in this case you will get a ketone. Now basically there is a reagent. If you want to add opposite, that is if you want to an alkene, if you want to add H here and OH here, what can you do? So what happened? In this case H has added here, OH has added here. Now if you want to add H here and OH here, that is opposite, if you want to convert this into this, let us say you want to add OH here and then tautomerize will give you aldehyde, there is a special reagent, and if you possible, if you can remember, that's fine. If you don't remember, that's also not problem, because this reaction is not in course. So SiA2BH and then H2O2OH minus. So this is a reagent SiA2BH. We'll discuss sometime in the class what is this reagent about. SiA2BH and H2O2OH minus, that will give you anti-Markovnikov addition of HOH. SiO2OH is called a dicyl borane. So let me write the name SiA2BH, and this is called disimyl borane. So this is the reagent that can be used sometime for anti-Markovnikov of addition. So let us finish it here. We'll discuss this one in the next class. Basically SiA is a abbreviation, and this is the abbreviation for this compound CS3 CH CS3 CH CH3. We'll discuss more about this sometime later. So this will give you anti-Markovnikov addition. Are you getting? We'll discuss the next problem. And there are so many noises. Okay, let us finish it here. We'll discuss the next problem.